Hello everyone. Figured I'd make another video, talk about binary stars. On my last video, sorry it was so long, but I wanted to cover, definitely cover what theories were, and how science is mainly theory based. I mean, there's very little science that is true fact, especially when you start talking about the universe. But I'm not going to get onto that again because I want to try to keep this video a little bit shorter than the last one. So that's the reason I'll get into the binary stars a little bit, but I'm not going to get into great detail because I don't want to sit here for, like the last video was about 40 minutes, and I don't want to sit here for 40 minutes, an hour or so, just trying to go into detail. But let's see, let's go to here. Here's the diagram that I've shown in several of my videos about how this is really what I really agree with on the binary, what a binary star would do. But now they're only showing the binary star orbiting our system, which that is how it would work. However, we are moving through our galaxy, so remember that as well. But not only is this star orbiting around us, but our star is also orbiting around it. So as this orbits like this, ours would orbit kind of like this. They would kind of swing around each other. So if this one swings here, our sun would swing like that. So with a binary star, you wouldn't have to worry about the star hitting our star. Well, you shouldn't, at least. Now, however, how close the star comes to orbit, that's a different story. Now, even if this star came, this close, and as their star swung around like this close, and you're gonna feel some effects of it, just depending on the size of the star. And also, of course, this star more than likely has planets around it, and I'll get into that theory here in a little bit. But I want to also thank Jiggy Graphics. He gave me a website that I had not been to, which here's that one diagram right here. It is. It's binaryresearchinstitute.org, which the name pretty much explains itself. What they do. Pretty much, there's your that's what I was talking about as for how the stars would orbit pretty much each other. Now, of course, they've got this one going pretty much a little bit further than that, and theirs swinging, so it would be in that aspect. It ain't saying that this is exactly what they're doing, but would do. But this kind of gives you an idea of how it would work. So, and also here, I mean, this website has a lot of great information on it. This right here is just the introduction. Like this right here is a great read. Talks about this man right here, where he actually did a lot of studies. With Cyrus, he actually was. I've read so much I cannot remember. Like that, I'm not going to get into detail because I don't want to have an extremely long video and for y'all to have to watch. So, but definitely recommend reading this site if you're really interested in the binary star theory. As again, like pretty much most of the science, especially when you deal with the galaxies, universes, spaces, theories, nothing's for fact. Because again, I'll just make a quick note that for anyone who's now watching this video, we've never been to any of these galaxies. So the current theories, they are theories that they have in place. They're just that, they're theories as how far these galaxies are away from us. As for now, within our solar system, the theory that they have would pretty much work because our system is moving through the galaxy. Our system is moving, but we'll see these planets around us, they're moving with us. Now, the theories that are in place, um, from one website, which I don't think I have it list open right now. No, because I got way too many to go through to try to find it. But pretty much just saying that it doesn't take that into calculation. And they also, on this website, on the Binary Research Institute.org, they go into detail about that here as well. Now, the only way that they're the way that a dynamic SS model, that is the model that the only way it will work is if we have a binary star, which the way that our sun is moving through the galaxy, it's becoming more clear that we probably are part of a binary star system. So again, this I really highly recommend going through this website, reading up on. If you're really interested, there's a lot of great data. I still haven't got to read all of it, especially a lot of when you get into calculations. There's a lot of research being done. I've got to look over and skim over some of it, but not all. It's going to take a lot of time. There's just a lot of websites I'm going through, a lot of information. It takes a long time. But back to here. Now there's two different stars that I'm looking at. There's two different theories. You have this theory that I was talking about in my last video, the Cw Leo. They're saying that Cw Leo could possibly be our binary star, because they're saying that the current theories are flawed, and they go into detail here and saying that that star system, or that star, is closer than what they are saying. And even with his calculations, then the other website where this was also listed, that's where they were saying that also the current theories did not put into effect that where our system is moving through the galaxy. So they actually throws it off even more, the current theories. So, like I said, the current theories works well for our own system, but not for the galaxies and the nebulas that are not part of their system. I mean, there's a lot of there's a lot more to it. You just have to read it, try to it's all the information is there. I mean, there's a few things you probably have to read over and over again, and you probably have to go to Google to search to understand. But I mean, a lot of this they do break it down to where it's fairly understandable. But some of the terms they use, you may have to go to Google to try to understand what the terms are. You gotta love Google. But here's this is what actually the Skyview team. I'll put them down below the video as well, along with some of these other websites, the links to these websites. These are a group of astronomers that is actually researching the Kepler's belt and the constellation Aquarius. Now, I've looked at this object before. This was actually the first object I was looking at and researching, but I was being when I looked up, I was being told that this was a camera a glare or a glitch, and so I was like, well, maybe maybe they're right. Maybe that is a camera glitch. So I just quit looking, and I started looking at the Cw Leo, because that caught my eye, especially with the infrared that the IRS picked up on it. Now, what you will find interesting about this is, well, also let's go for the background here. Like, let's see your stars, your galaxies, everything here. Now, some places are I've read on the web, because I was wondering how old this is. Some are saying that it's from 1958. So that means what we're looking at is 50-some years old, which is kind of hard to believe, and it's kind of sad if it is, considering that NASA has the amount of satellites NASA has out in space. That kind of makes you wonder why they won't let us see our current system. It wouldn't be that hard to paste over all of this. Okay, and another thing that's a little bit suspicious is watch what happens. Okay, here is where this object is. Now if you go to IRIS and you get infrared, voila, it is dark. Now I do understand that this happened on Google, and there was a big old square there, and I do understand that when they pieced all this stuff together, especially on Google Sky, but they only had a one square image that was missing. This has a humongous chunk of space that is missing, and it's the same on the other side. Now, I can understand that maybe that could happen if they pieced it together, but that is fixable, and they have not fixed it. Now, if that was a brown dwarf, then this right here, and if this was as close as Kepler's belt, you would see a very bright image, especially in infrared as for heat. So maybe that's just a theory, a thought. This is my fault. That's what could be possible. It's just a little suspicious of why they have not fixed this. Now the IRIS infrared is from 1983, I believe. Now I'm wondering if maybe they updated the starters and the galaxies in 1983 as well. I'm not really certain. I can't really find a definite answer on that. I've Googled it quite a bit, but if it is, even 1983 is a little bit on the pathetic side. With all the satellites, like again, that NASA has out in our own solar system, they could easily paint an image of the sky with ease. Now, why they do not want us to see what's out there is a little, I don't know what word you want to use. It makes you wonder. It does make you wonder. Now, you can find other images on the internet, and that's what I plan on just a little research to do to try to find past images of this area, along with maybe even Cw Leo. So my eyes have turned more towards this area now because there is actually a group of astronomers, which is the SkyView team, that is actually tracking an object in Kepler's belt. I highly recommend that you subscribe to this channel. Currently they only have 7 videos. You wonder, well, why do they only have 7 videos? But just watch the first one and they'll have a description. Something went on with their team or something. They've had other videos in the past. I don't know what their channel was called at that time, but they've just pretty much started a new channel. So, but every one of these videos are great to watch, especially if you have an open mind and you believe in the binary star. And what they're saying is that there's an object in the Kepler's belt that is heading our way, or at least around our way. It could be our binary star, and it actually has objects around it, like this right here. You can see it. This would be our binary star, and it has looks like objects, be planets. Now, whether this is and it shows up red, so that would definitely be a dwarf star. And what is I pretty much, they're doing what I can't do because I don't have the no kind of infrared scope or any kind of telescope that could actually view to that kind of point. It would be nice to have the technology to do that, but currently I don't. So I've got to rely on astronomers like this and go by what they're showing, which they have some, like I said, great information, and just I really highly recommend that you watch the videos. Back to, let's go with Microsoft, and let's look at this. The coordinates for this one in Aquarius is, I've got here 22 hours, 35 minutes, 53 seconds. That's a degree of -4, 25 by 17.9. That will bring you to that. Now, if you kind of look at it, kind of even looks. Now, when I first looked at it, I thought maybe it was a comet swarm, which it could possibly be, but in a way, from the red, it could definitely be maybe the dwarf star behind there, and the planets around it, or even objects. If it's going to the Kepler's belt or near the Kepler's belt, then it's going to be picking up different objects. It's going to be picking up comets, asteroids, I mean, you're talking about a star that's moving through a debris field. So I'm sure that some of these could be planets, but they could also be other objects if this is our dwarf star. Now, there are other little telescope flares on here, but this doesn't look really like a flare. I know they just, I took it the first time when I was researching and looking at this, and I was like, well, maybe maybe they're right, maybe it's a flare. But one thing with flare, you can usually see through it. I'm not seeing through this one. I mean, maybe there's just not no stars behind there, but I'm not seeing through it. I mean, on the edge, maybe, I don't know if that's even a star or if that's just like part of it, because it looks like it's part of the whether that is the dust, the iron, maybe they call it like iron dust, or it's like I said, this looks just maybe them are comets or something around it. I don't know. Just from the trail that's leading, I don't know. This is just a guess. Like I said, I'm just looking at it, guessing at it. But what's really interesting is watch this. Let us go to Google Sky. This is the same object in the same area. Now, you can't zoom in close to Google Sky because you get this. However, when you look at it, notice the objects are the same. It's just a different color. Now, and you cannot see through this one either. You can't see this, no kind of stars. Notice that. So that is pretty much like I said, a flare. You can usually see through a flare at some point. You can't see through this. So that does make it kind of interesting. Now, if you want to see a flare, here's in the Gemini. Here's a flare for you. Let us take this out. Put in these coordinates in Gemini. And let's go to Gemini. Alright, and as it loads. Alright, now when you first see it, you're like, oh wow, there's another star. But now notice, this is a flare. Notice the stars behind it. You can see through this one with ease, even the faintest ones back in behind it. Not just the bright ones, but also the faint ones. You can see through it. There's one, there's a star, there's a star, there's a star, there's a star. This is a flare. That would definitely be a lens flare. You can, or it could, maybe there's some object there, and I'm still not saying it's an object. No, this is a flare. This would definitely, I would call this a flare, because like I said, you can definitely see through this one. And that right there would just be the space. That's a flare for you. You can see through. And there's, I think I've seen maybe another one here and there. The flares. Now let's go back to Aquarius. Like I said, we'll put these coordinates so you can look at it yourself. Alright, we'll look at this one more time. And again, notice you cannot see through this one unless there's no stars behind it, which is possible, but I just don't see that. More, even this black space, I mean, you can kind of see like it has detail to it. Even, it's different. And if it is a lens flare, then that is it's definitely different. And which, like I said, I quit researching it the first time because people were saying it's a lens flare. But what has made me start looking again was the Skyview, the Skyview team of astronomers. This is exactly where they're looking at, and by watching these videos, this is pretty much exactly what they're seeing. I mean, they're seeing a red object, but then they're seeing the planets around it, which with how this is, of course I can't even say planets like this, but the planets would be like this. If you got a red object, the planet's going to be in this area around it. Of course, like I said, this could be other debris as well, going through coming into the Kepler's belt, so that of course it's going to pick up debris. Now, and also another thing I would recommend that you would do is on YouTube, keep check on the sun. Look at like the solar flares, not just the solar flares, but watch what is going into the sun. You'll notice that comets are actually, I'll go through all of them here, are coming in a different direction than what they should be coming in. So keep an eye on that. You'll notice that some, I've seen one either today or the other day, that even it caught someone's eye, said that a comet was going into it in the wrong direction. That's not the first time. It's a lot of the comets and debris has been heading into the sun more than usual, especially when they're coming in a different direction, in a direction the comet should not be coming in. So that kind of makes me agree with this even more, because you're going to get comets coming in the direction that they would normally not be coming in. But this, like, there would be comet swarms. Let's see. Oh, what was that? I can't remember what I had on there now. Let's look at that. I was going to talk about something else. Aquarius, like here on Solar Scope, where the object would be. Let's see if the time's right for one. Yes. We're here, so we've got a great view of Aquarius right now. So you can see Neptune, although Neptune is getting ready to lower below to where we cannot see it. Let me see. I can see it tonight. I see it in the sky easily to be seen. Where's Neptune? Where did he go? There's Mercury. The sun's ready to come up, and a lot of people are seeing, like I said, you got Mercury, Venus, the Sun, Jupiter. Jupiter is actually really close. I'll show you that. Where's Neptune? Aquarius. I've lost it. There's the moon. It's right on the I so lost Aquarius. There it is. Okay, it's not down yet. So it was a little bit higher, so you can still see it. But there's your Neptune. The object will be coming in around this area, I believe it is. Solar, still, yep. The closest I could find to it would be this, which I'm going to look this up. I'll look up the, haven't had the chance yet to look up the coordinates. This one, 35 minutes, 53 seconds. This one is 22 hours, 38 minutes, and 3.5 seconds. So it's a little off. Now the degree on the object in Aquarius is -4 by 25 by 17.9. This right here is -4 by 25 by 22.8. So it's down right there on the dot. Now I don't think that's it. I don't know if it is, or that's probably, it's got to be a star of some sort. They don't have it listed though. I will look to see what this is, and I'll get back with you on another video on that one. As for where this would be located, here's your Aquarius. There's, like I said, there's Neptune. The object would be in this area right here. So again, on Solar Scope, it would be like right in this area. So that's really most of this video. I just want to talk about binary stars a little bit. I don't want to make it extremely long or getting close to 25 minutes. Want to keep this a little bit shorter than the last one. If you have any questions, just let me know. Like I said, I'll put the links to the Binary Research Institute.org on there. I definitely recommend you go there if you're interested in the binary star theory. Remember that pretty much all science, especially when you're talking in the universe, outer space, is theory based. Again, until we as humans go to any of these systems to find out exactly if how far away they are, we can't say that they are truly say that they are light years away, thousands of light years away, because we're using a theory to calculate that. So, and what this is, if this theory right here is correct, then these stars would actually be, well, this isn't, well, that theory isn't. Yeah, actually, yeah, because even this one would prove that the theory that they used would be incorrect. So it's going to be it'd be interesting, but even this, it will remain a theory really until we see another star. When we see another star, then of course it would become a fact. Well, not really a fact, until even if another star came in here, then we would have to be proven that they are orbiting each other, which more than likely they would be. So science takes a long time, but usually there's very few facts in science. Science always changes. That's the reason everything's a theory. And like I said, I won't get into that. If you want to listen to me ramble on about theories, like I said, watch the prior video to this one. It's about 40 minutes long, so it talks about theories quite a bit. But really, if you're really interested in this object, like I said, what's got my interest back into this object, like this was the first one I was actually looking at before I was looking at Cw Leo, which I will continue looking at Cw Leo. But I'm putting more into this because there's a group of astronomers now that I've found. Thank you to Jiggy Graphics again, because I had watched a couple of these videos, but I hadn't watched them all. He asked me if I had seen these videos or have heard of the Skyview team, which I had. I just didn't subscribe to their channel, which I have now. And I'm glad I did, because I've watched the remaining videos, and like I said, every one of them are awesome videos. Thank you again, Jiggy Graphics, for giving me that website and having me take another look at this group of astronomers. And I will continue researching on that area, and also researching, like I said, I will continue looking at Cw Leo, and also because it could be closer, and it could also be a binary star. But with a group of astronomers that are looking at Aquarius, and actually they're saying that this is actually coming towards us, this object. They won't name, they will not name it as Nibiru, but they're thinking it's a dwarf star, because another thing that they have found is Pluto, Uranus, Neptune, all of those planets, even Mars, they're warming up. Now, as they was in one of these videos, like maybe it is their star, maybe it's our sun warming up, but if you've got Pluto and Neptune warming up, even I don't know how many degrees they're warming up, but even if it's by a few degrees, if they're warming up just by a few degrees, then planet Earth should be warming up way more than Neptune or Pluto. So even if Neptune and Pluto is warming up, let's say 5 degrees, then this planet should warm up by, just by guess, by 15 degrees with ease, and it's not maybe 20, because I mean, look how far the distance is between. If I get back over here, just kind of will give you a little bit of an idea. I mean, there's a huge difference. I just don't really truly show you, but the distance out there it's far. I mean, just watch the orbits, how quick these inner planets orbit compared to the ones on out. That will give you an idea exactly how far these other planets are out. And that's this, where's Neptune? Back here. So, you imagine if these are warming up, Pluto, Neptune, Uranus, if they're warming up, imagine if they're just warming up by a couple degrees, then that means these inner planets like us would have to be warming up by, even if, let's say, 2 degrees. I mean, seriously, if for this to warm up 2 degrees, these would have to warm up by at least like 10 to 15, I mean, around 10 or so. If 10, 15, and we've only warmed up by a few degrees. So, is it because of greenhouse gases and stuff, or is it because there's actually another star coming into play? You know, who knows? I mean, that's just a theory, a thought. Because it don't make sense for the sun to be warming up. And because if it was, then our planet would be warmer than what these out here would be. So, with these other planets warming up, and especially in this area, that kind of tells you something. Something possibly is coming that way. And with the images that they're showing, that it gives more, I would say proof. Well, I guess in a way proof that there is something out there. So, again, highly recommend that you watch their videos and join their channel. It seems like they're doing some great research, and definitely I'm glad that found these astronomers, because they've got, like I said, they've got technology that I don't have, so I definitely can rely on them to give some great images of what that I cannot see myself. Hope that you enjoyed this video. If you have any questions, feel free to ask. If you have any comments, feel free. Any other theories, feel free to leave. Like I said, it's just really interesting. Especially this. I shouldn't have quit researching it by just finding just a couple things saying it was a camera glare. I should have a telescope glare. I should have looked into it more, because honestly, you can't see through this one. As you can see through the other glares. And even on the Google sky, you can't see through it. Oh, Google. Drive me nuts sometimes. Well, I think Google's not going to work for me now. There it goes. Let's zoom in, Google. And then, did I move? I hope it didn't move me. Google's done. I think they're having some issues. The search wouldn't work, so I think Google's having some problems. Yeah, they're having problems. Where did my little green buddy go? Oh, degrees are the same. 22. That's a little weird. Maybe it should still be there. Surely they haven't taken that out. I guess I'll find out later. 22, 3, 4. Okay, that's well, have my video just in case that they have decided to remove that image. That's a little bit strange. Microsoft, maybe they won't. So I'll go back to Google Sky tomorrow and see if that image is back. Maybe they're just having some problems. Surely they have not removed that. I don't think I moved. Can't miss that green object. Wow, that would be pretty tacky if they removed that. And I've removed it while I was videotaping. I'm off by a few degrees. Maybe I'm off by a few degrees. Oh yeah, I'm off. How did that happen? Oh, how did I get down there? That's messed up. There we go. Okay. Okay, they had just something went wrong. Okay. They already say, like Google, you just not, you just did not do that. So they didn't. Okay, there we go. It's still there. So again, it's some interesting stuff. But I'll go. I guess it's about time for me to head to bed since it's about 4 in the morning. I've been doing a lot of reading, so I'm getting pretty tired. Hopefully that made sense to this video. I wanted to make it earlier, but like I said, I kept on reading and I kind of got lost track of time. So about 4 in the morning. So let me go to the actual time. That would be the reason I couldn't find it. That's where I'm moving. Okay. Again, also I was going to show you something. It's pretty interesting, pretty cool. What's going to happen? See here. Here's Earth. Swing around here. What is this? What was that? I was messing around with this. Maybe it was earlier. Can't remember. It might be a later date, but things were going to line up and it was going to be a neat looking show, which you can see in the sky. So, but I'll look at that later and I'll put that on a later video. I'll quit rambling on and hope you all enjoy the video, and I'll talk to you soon. Take care.